Today's going to be our first day where we look at exponents. So most of this should be a review from last year. So remember an exponent, if we have x to the n power, that's as if we just multiply it out n times. So the product rule, that's if we have x to the m times x to the n. And let's flip to the inside here, and let's see if we can remember what the product rule is. So if we had x to the third times x to the fourth, that's, let's see, x, 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 x. So that's really x to the seventh. So if we go back here, what's our rule for the product rule is we have to add those. So this is x to the m plus n. If we go to the power rule, let's say that's x to the m to the n. So the nice thing about this is I like exponents because we can always just write it out. X to the third to the fourth. Well, that's x to the third, x to the third, x to the third, x to the third. We have it 4 times. X, 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 x. So that's x to the 12th. So our rule for the power rule would be multiply those, so that's x to the m times n. The distributive product, let's say we have ab to the n power. So if we go down here, let's say we have ab to the 4th power. Well, that's ab times ab times ab times ab. So that would be a to the 4th times b to the 4th. Let's see, where is that up here? So this, we distribute it, so it's a to the n, b to the n. Negative exponents. We looked at that pattern earlier, so if we have a to the negative n, that's equal to 1 over a to the n. Our quotient rule, if we have x to the m over x to the n, so let's take a look at that one. And then we'll come back and do negatives. So if we have x to the 5th over x squared, 1, 2, 3, 4, 5, over 2 of them, reduce out, reduce out. So we really just have x to the 3rd. So we subtract. So this would be x to the m minus n. The zero exponent rule. This might just be one that you have to remember. Anything to the 0 power is 1. And we'll take a look at how that works here. So with our division, it's like saying if we had x to the 5th over x to the 5th, we know that that's equal to 1, but our quotient rule tells us to subtract, so this is x to the 5 minus 5, which is x to the 0, so therefore it's 1. And I realize we forgot negative exponents. So if we had x to the negative 5, this is 1 over x to the power of 5. And it works on the denominators too. If we had 1x to the negative 5th, it goes to the other side of the fraction. So this is just positive x to the 5th. And the last one, the distributive rule of quotients. So if we had a over b to the n power. So if we had a over b to the 3rd, so that's a over b times a over b. So that would be a to the 3rd, b to the 3rd. So that distributive rule, just like when there's parentheses, we have to distribute it. So a to the nth over b to the n. Now the more complicated part is when there's a whole bunch of these, because those are pretty easy when there's just single ones here. So what we're going to do is we're going to take a look at a couple problems that have used multiple ones of these rules. So if you had to simplify 2k to the 3rd times k squared over k to the negative 3. And you can do these in any order. I tend to get rid of negatives first. So this is 2k to the 3rd, k squared, and then this one right here would become k to the 3rd. So what does that equal? Well, 2 3k's, 4 5's, 8k's. So 2k to the 8th. So the second one we're going to look at is, let's say we have x to the negative third to the fourth times x to the fourth 2x to the negative 3. And this is times. It looks like multiply. Well, let's see. I'm going to get rid of parentheses first. So this would be x to the negative 12 times x to the fourth 2, and then this would be x to the negative 3. Let's see if we add these together. Negative 12 plus 4 is negative 8, minus 3 is negative 11. So x to the negative 11 over 2, and then we need to flip that. So 1 over 2x to the 11th. Now, you could have done this a different way too. It is nice to get rid of the parentheses first. So if this is still x to the negative 12, x to the fourth over 2x to the negative 3, let's say we flipped those negatives first. So this is x to the fourth stays, x to the 12th flips, the 2 stays, x to the third stays. And so this ends up being x to the 7th over x to the 12th times 2. And let's see, I should have got a right answer here because there's more on the bottom, so this would be 2x to the 5th. Let's see, did I add something wrong here? Negative 3 times 12, negative 12. Oh, I know what it was. This is my bad. So right here, this should have been x to the positive 3 when you flip it. So that's totally wrong there. I was going to say you should get the same answer. So this is really x to the negative 5th, which when you flip it would be x to the 5th. So that is a nice way to double check it. Is try to do it a different way and see if you get the same answers. So the third one here, let's say we have 2x to the third z squared to the third power divided by x to the third y to the fourth z squared x to the negative 4 z cubed. So there's a lot going on. So first I'm going to take care of these parentheses. So this is 2 squared x to the 6th z to the 6th. In the bottom would all just stay x cubed y to the 4th z squared x to the negative 4 z cubed. Maybe I'll combine the top and bottom. So the top 2 squared, 4 x to the 6 z to the 6th. But let's look at x's on the bottom. That's not an x. So we would have x to the negative 1, y to the 4th. And let's see, our z's to the 5th. Well, that x needs to go on top, so 4 x to the 6th, z to the 6th, x to the 1st, y to the 4th, z to the 5th. So let's see, we have 4 on the top, x to the 7th. Z's, there's more on top, so 1 more, and then y to the 4th on the bottom. And then the last one we're going to take a look at. Let's say we have 2pm to the negative 1 q to the 0 times 2m to the negative 1 p cubed over 2pq squared. Well, let's see, those parentheses we don't need to distribute anything, so I'm just going to combine what we have on the top. So 2 times 2, 4. Let's see our p's here. P to the 4th. Our m's, m to the negative 2, and anything to the 0 power is just 1. So now we have 2pq squared. Well, simplifying, 4 over 2 is 2. Where are there more p's? On the top, so that would be p to the 3rd. The m has to flip to the bottom, and the q stays on the bottom.